Hi everyone, welcome to machine learning using Python. We are getting into the use case phase, and the first one to be on this is forecasting. So Jamit Wasawa is here to address the forecasting, how we go about. It may be theoretical to start with, and we'll get into details later. But at this time, I will hand over to Jamit Wasawa to manage, and we let's hear from him what he has to say, and we'll follow up with one more session later. So this is module 9, session 1. Sorry, module 9, part 1, session 17. Thanks. Jamit, go ahead, take over from here.
Thank you, and hi everyone. This is machine learning using Python, and today's topic is forecasting. So uh, let's start our session and discuss the learning objective for today's session. Okay, sorry for this. So the learning goals for session 17 or today's session is what and why of forecasting, means what is forecasting and why do we use it, what is time series and how time series is used in forecasting, and components of forecasting techniques such as moving average and exponential smoothing, which will be discussed in this session in module 9 part 1 session 17. In the other things will be discussed in the next sessions that will be continuing after completion of this one. Just a second, I'm having some problem speaking. Just a second. So yeah, let's continue. So these are the forecasting techniques that we'll be discussing today with moving average and exponential smoothing. So first of all, what and why of forecasting? What is forecasting? It's a process that enables organizations to predict future trends and demand for products and services, forming the backbone of strategic planning. Now, forecasting is not when we are talking about strategic planning, we are not only talking about the demand of the product and services that the company is giving, but also for how the organization is carrying out those things. So as we move forward, we'll get to know that forecasting is not limited to numbers of business, but also for the planning of execution of those strategies that the organizations uh, gain from using forecasting. So why forecasting? By leveraging the past data and statistical methods, we try to forecast the let's say if we are talking about sales, then we are trying to project sales figures for the upcoming quarter or estimating the manpower needs for a new project. Accurate forecasting serves a key driver for both the short-term and the long-term planning. So forecasting not only serves for the short-term plannings. Short-term plannings can be for something, a trend going on for the organization that it is in, or a long-term planning for executing a very long-term plan that the organization thinks is going to be uh, beneficial for themselves in long term. So serving both the purposes of or covering both the purposes for both the short and the long-term planning. As organizations strive to enhance their efficiency and responsiveness, the ability to effectively forecast demand not only impacts operational capacities, but also plays a pivotal role in maximizing the profitability and sustaining competitive advantage. So, as we are talking about predicting from the past data or using the past data, we, as we have been discussing in this whole ML course that we started with predictive analytics. So we are using past data in both the predictive analytics and forecasting. So uh, what is it? Are they same or are they different? So no, predictive analytics is a different thing and forecasting is a different thing. Both use past data, but it the purpose of both of them are different. So predictive analytics is a broader field that uses various statistical techniques, including machine learning and data mining, to analyze current and historical data to make predictions about future outcomes. It seeks to identify patterns, correlations, and trends in the data to predict various outcomes, not limited to time series. And applications can include customer behavior predictions, risk assessment, and fraud detections. Methods of predictive analytics can be regression, classification, and clustering methods and stuff. For forecasting, it involves predicting values based on historical data, typically focusing on time series data. Data points collect, which is data points collected at regular intervals. So it aims to estimate future outcomes over a specified time period, often used in contexts like sales forecasting, weather predictions, economic trends, etc. So moving averages and exponential smoothing and auto-regressive integrated moving average. These are all the techniques that are used in forecasting. Today in this session, we'll be discussing with a moving average and exponential smoothing. So the key differences between the predictive analytics and the forecasting is forecasting is explicitly concerned with predicting future values based uh, over time, while predictive analytics can involve predicting outcomes that are not necessarily tied to time dimension. So forecasting typically relies on the time series data, whereas predictive analytics can use various types of data, including categorical and unstructured data. So a few of the challenging examples in forecasting problems. So demand for product and service is not only is not the only application for forecasting. Even manpower planning requires the use of sophisticated models. So this is what I meant when I was talking about only sales or business goals, but also the execution of those goals. It forecasting helps us to plan those execution as well, uh, which involves manpower planning. So, Indian information technology uh, companies struggle to manage the right level of manpower for each skill required to manage their business. This would involve forecasting business opportunities, skills required to manage current and future projects, and so on. The second one is our parts of Boeing 747 400. So that plane has 6 million parts, and several of them are mission critical. Several of them are unique parts. So at the time of a non-availability of those mission critical parts can result in aircraft on ground, which can be very expensive for the airlines. Then comes the Walmart and the comparison with Amazon. So Walmart sells over 142K products through their super centers, and Walmart uh, is at a disadvantage when compared to Amazon, as Amazon does not have to predict the demand for all the products they sell at their portal, whereas Walmart has to maintain the stock for each and every products they sell and predict the demand of the products as accurately as possible. So these were the three real world examples that exist for the companies. Next topic is time series. So, uh, time series in short can be said as uh, a data collected at regular intervals of time. So, but what is time series according to Wikipedia? A time series is a data of data points indexed in time order. Most commonly, a time series is a sequence taken at a successive equally spaced points in time. Thus, it is a sequence of discrete time data. So, a time series can be heights of ocean tides, then a count of sunspots and stuff. So, why do we use a time series? Because it captures the patterns, trends, and seasonal variations in historical data, allowing for more accurate predictions of future values based on observed behaviors over time. When dealing with time series data, uh, if we call it data YT, which is a random variable, usually collected at regular intervals in a chronological order. If the time series contains observations of just a single variable, uh, which can be demand for a product at time t, then it is termed as univariate time series. But if there are more than one variables, then it is called as a multivariate time series, which can contain the time series data for demand of the product as well as price at that time t, amount of money spent by the company on the promotion of that product, what are the competitors price at the same given time. Now there are different components to this time series data. First is the trend component, which is a consistent long-term upward or downward movement of the data. Then comes the seasonal component, which shows a repetitive upward and downward movement. You can think of it as sales going up at the time of festivals. You can say it for Diwali or Christmas or any other festivals during the year. So those are the seasonal components that around the year they can be repeated upward or downward fluctuations due to different reasons. Then comes the cyclic component, CT. Cyclic component is a fluctuation around the trend line in a random interval that happens due to macroeconomic changes such as recession, unemployment, etc. So it cyclic cyclic components have repetitive patterns with time between repetitions of more than a year. Whereas in case of seasonality that we discussed previously, the fluctuations are observed within a calendar year and are driven by factors of festivals and customs that exist in the society. The major difference both of them is that seasonal fluctuations occur at fixed period within a calendar year, whereas cyclic fluctuations have random time between the fluctuations. So the periodicity of the seasonal fluctuation is a constant, whereas the periodicity of the cyclic fluctuation is not constant. Then comes the irregular components, which are the white noise or random uncorrelated changes that follow a normal distribution with mean value of zero and constant variance. So after discussing the components of time series data, let's discuss the forecasting techniques, which are moving average, MA, exponential smoothing, then auto-regressive integrated moving average, AIMA. So based on these forecasting techniques, there are statistical models as well from the same name. In addition to those which was stated before, the auto-regressive and moving average is also added for ARMA. So you can see that the most of the models are mostly they are ordered in terms of complexity. So first are the most least complex to the most complex. So using more complex mathematical model does not guarantee a more accurate forecast. You can see the note at the very end. So simple moving average technique may outperform complex ARIMA models in many cases. So starting with our first forecasting technique, which is moving average, one of the most simplest forecasting technique, which forecasts the future value of a time series data using average of the n past observations. So the forecasted value for time t plus 1 is given by the formula. You can see ft plus 1 equals to 1 by n for the number of observation, and the summation of from k equals to t plus 1 minus n to t for the yk data. So here ft plus 1 is the forecasted value, n is the number of past observations that we want to forecast on the moving average, and yk represents the actual observed values, and the range of k is from t plus 1 minus n to t. So in this, for understanding this moving average, we'll be using a data set called, which is for from a Kesh shampoo, which is sold in 100 ml bottles by a manufacturer and distributor named V Cell Beauty, WSB. So first we import the data set and get the first few, display the first few values. You can see the contents of the data set as well as the features of the data set. So month, sale quantity, promotion expenses, and competition promotion. So the data set contains a quantity of 100 ml bottles sold during each month for a period of 48 months. So promotional expense is incurred by the companies displayed, and whether the competition was on promotion or not is implied. One for competition was on promotion and zero is not. So when we plot the graph for the sales on the uh, sales of the shampoo for the months that are present in the data set, this is how the graph we get. We start pretty down, but overall we see an upward trend. When we get the info regarding the data set that we have, uh, you can see that we have 48 entries for 48 months and uh, four four columns. So first we calculate the moving average. We'll calculate moving average with the help of three methods, which are rolling, mean, and shift. So what does rolling mean? What we are trying to do is we have 48 months and we want to calculate the moving average of with the window or period of 12 months. Not period, it will be confusing. So let's just keep it window. So we want to calculate in the window of 12 months. So when, so you can see the components rolling, mean, and shifts are set. So starting with rolling, and it takes a parameter window. So this method creates a rolling window object that allows calculation over a specified number of consecutive data points in data frame or series. Then comes the mean for calculation of the mean of those values for each rolling window. And the shift and periods equals to 1 means that we shift the time series or data specified number by 1. So the shift also takes different
Dennis,
parameters, which are, yes,
Dennis, one sec. So does it mean that we are looking for 30 days, 1 month window? That is one,
yes,
and average of those 30 days. Then another 30 days, maybe another month. Average
yeah,
of that. Like that, if you can have a window of 12 months, each month the average is mean for that particular. That is the rolling window, right?
yeah,
Am I getting correct? Okay,
yeah, yeah,
thanks. I appreciate that. That's
yeah.
good enough. Go
Okay,
continue. Continue.
okay, sure. So, uh, so the reason, so as sir wanted to clear the things, the rolling window help or the moving average and the rolling window helps us to keep the graph smoothened out. So as we keep the 12 as the window that we have taken is 12. So when we use the shift and period equals to 1 means we are shifting to by 1 down for the same 12 months. So which when we plot these average values all together, it gives us the a smooth graph which helps us to interpret it better and easier way. So those are the reason mean to calculate the average, shift to uh, shift the data in the series or the data frame form by 1. So the shift also takes periods, access, and fill value as the parameters. So periods is the number of periods to shift. By default, it's a 1. So a positive number shift the data down forward in the time, while a negative number shifts the data backward in the time. Axis specifies whether to shift rows or columns. And fill value, the optional parameter allows you to fill in the newly created nan values with a specific value instead of leaving them as nan. Here we are only using the periods equals periods parameter for 1. So also we are forecasting the sales quantity and saving them into mean average for 12 years. So after just a second. Uh, so so this was the trend that was from the data set that we got. Okay, when we plotted using the months and the quantities of sale, and we have total 48 months. So it shows us the trend of the 48 months. Now, when we get the info and stuff for just knowing about the data set and getting the calculating the moving average of with the window value of 12 and calculating it. This is the first we'll be formatting those values so that they don't go way out. And as you know that we are calculating it for the 12 window, the first 12 values will be none, and then we'll be giving the predicted values from here. So from 12 to, I hope you are able to see it. I will just zoom it a bit because it will contain 48 total values. So starting from 12, we have these figures that were forecasted, and we have it till 47th index. So we have made the forecasting now. Now we want to evaluate how much of our statistical models are good at it. So for evaluating this accuracy of the forecast, we'll be using the root mean square error and mean absolute percentage error, MAPE, which are two of the most accuracy measures for forecasting. So starting with root mean square, uh, I'm sorry for this mistakes. So starting with mean absolute percentage error, MAPE, which is one of the most popular forecasting accuracy measures. So you can see the mathematical representation of mean absolute percentage error, how it is calculated. YT for the value as minus the forecasted value divided by YT into the 100, also multiplied by 1 by n for the values taken. So for calculating this mean absolute percentage error, we'll be defining a function and calculating it for the actual and the predicted values. And when we do it for our sales quantity in the WSB DF, it will be from 36th value. So our MAPE, or the mean absolute percentage error, comes down to 14.04. So the forecasting using moving average gives us the MAPE of 14.04%. Then the next technique is root mean squared error. Root mean squared error is pretty straightforward. The You can see the mathematical expression for it, which is square root of 1 by n of summation from summation of t equals to 1 to n for yt minus ft whole square. Yt's are the focus. Sorry, yt's are the actual values, whereas forecasting ft are the forecasted values. So we get the when we calculate the root mean square error for our statistical model that we have uh, gotten, and the forecasting that we did, we get the standard deviation of 73,000 734,725.83. Now, after knowing about the moving average and how it works, it simply takes all the values that are in the past and uh, calculate the average for the window that we gave. In the past, we have given the window of 12, and the shift value equals to 1. But the thing is that moving average, it uses the same kind of, it treats all the values from the past to present in the same way. Now, exponential smoothing um, addresses this drawback of moving average that is present, which solves the problem for which solves the problem for not having to give more or equal weightage to the values that were used in the very past of it, and the more recent values are given more weightage. So the mathematical representation of the exponential smoothing is ft plus 1 equals to alpha yt plus 1 minus alpha into yt, where alpha is the smoothing constant and its value lies between 0 to 1. Ft plus 1 is the forecasted value at time t plus 1, and yt is the actual value at time t. So exponential for calculating exponential smoothing, we use the EWM method, which is from pandas, to calculate the exponential weighted functions, which includes statistics like mean and variance, applying an exponentially decreasing weight to observation as they age. So this is particularly useful in the time series analysis, where more recent data points are often considered more relevant than the older ones. So uh, we are using this uh, adding another column EWM for storing the values for the exponential smoothing. So we use we store the values of them, and you can see the values from 36 to 47 that we have given, that we got for the forecasting using the exponential smoothing in the very last column of EWM. So you can also see that the EWM contains a parameter called alpha, which is given the value of 0.2. So it means that for more recent data, 20% of weightage is given, and for the rest of it, 80% is divided, but in a depreciating manner. So as old uh, the observation is going to be, the weight will be given much less to it. So as we have used this EWM statistical model, we will use the get_map method, get_map function that we just formed, and instead of for moving average, we got the score of 14 point something, but for EWM we are getting 11.15%. So which is a kind of an improvement for our model, statistical model. When we plot the graph for this exponential moving average, the moving average and the simple exponential smoothing SES assume a fairly steady time series data with no significant trend and seasonal or cyclical components. So the data is stationary. However, many data sets will have trend and seasonality. So you can find for data sets that have trends or seasonality, on which we can use the EWM method. Now we'll decompose the time series based on the components of time series that we have discussed, which was TT represents trend component, represents seasonal component, cyclical component is represented by CT, and irregular component is represented by IT. So there are two types of models. One are additive models and other one is multiplicative models. But the additive models, they assume the seasonality and cyclical components are independent of the trend component, and additive components are not very common since in many cases the seasonal component may not be independent of the trend. Whereas in multiplicative models are more common and they are better fit for many data sets, and they also get into account the seasonality effect on the sales. So for example, there is Diwali, and it does not result in constant increase of sales over the years. The increase in sales of cars during festival season is not just 100 units every year, but rather it's a multiplicative effect on sales based on the trend over the years, like 10% additional units based on the trend in the current year. So, what So, a comment thought of on both the additive and the multiplicative one. For building the forecasting model, only trend and seasonality components are used. So, to estimate the cyclical component, we need a large data set, and for an organization, the a typical business cycle uh, runs for 58 months, and having a data for over 10 years is very the chances are very less. So for moving further with our discussion, and for the same data set, we'll be applying the decomposition of time series data, or decomposing a time series data, which will be used using the stats model time series analysis, and we'll be using seasonal decompose method from it to know the trend, seasonal, and residuals. And as we have discussed it for the window of 12 months, we'll be going further with the same. So this is how the stat models are. Seasonal decompose is used. It takes the sales quantity, and the model we used is multiplicative, and we just discussed why we used a multiplicative instead of additive. And lastly, the period value, which is for 12. And when we plot the graph for the decompose, you can see that uh, the on the y-axis there is a residual seasonal trend, and observed should also be appearing on that, but for some size reason it is appearing on uh, in the space of title. But you can see the trend is moving upward. There are seasonal trends also appearing, and you can see that over the time, same kind of seasonal trend is present, and there are residual as well. So so we so just to continue with the Jupyter Notebooks summary for the moving average that we left off at. This is the trend line that we get for the moving average. Then we calculated the MAP or mean absolute percentage error, and we got for moving average 14.04%, and this was the standard deviation that was given by root mean square error. Then we discussed about the exponential smoothing, which addresses a drawback from moving average and giving weights to the more recent ones. These were we added the EWM, used EWM method and added the EWM, and then used it in the data set. Uh, we get an improvement of 11.15% for the mean absolute percentage error. And when plotting the graph, you can see that it almost doesn't show much of the trend uh, if we go according to the EWM, which is the dotted line over here. Then lastly, we talked about the decomposition of the time series data for the EWM model that we created using the multiplicative model. Sorry, the decomposition of time series that we discussed using the multiplicative model, not EWM, sorry. So this was the plot that was created. So to summarize today's session, we started with the what and why of forecasting, discussed why it was different than predictive analytics and why as forecasting only deals with a time series, then discussed what was time series, components of forecasting were discussed, as well as the components of time series as well. Then we discussed two forecasting techniques, moving average and exponential smoothing, evaluated those forecasting techniques using RMSE and MAPE, and then in the end, we decomposed the time series data using the seasonal decompose. So this was it for the forecasting part one. Next, we'll be covering the ARMA and ARIMA models. So thank you for listening.
Thank you, Jamit. It was an excellent presentation, and look forward to your next session on the MAPE and other ARIMA and whatever you were talking about.
Yeah,
Good show. Let's close this on a good evening today, and thanks for the session 17. Let's look forward to session 18, and all this recording will be posted by midnight so that whatever last and these two will be up in the series. So thank you very much, Jamit, and have a great day. And look forward to working with you on the next session. Thank you.
thank you so much, sir.
Bye.
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 Should I stop the recording?